Hi, I am Lakshmi Harshini Kuchibutla. Our group is working on a project titled Movie Success Prediction. We chose this topic because, regardless of age, diversity, and region, most of the people enjoy watching series, movies, and dramas. Each individual can have variety of opinions and preferences for the same movie. But there must be something for which most audiences are attracted to. We thought it could be interesting to predict the success of different movies using some real time tweets and comments so that it can help the directors understand which type of stories most people tend to watch. We use large datasets extracted from Twitter comments for prediction. The outcome of this project will likely determine the attitude of people towards a movie, estimated revenue, and sales for the movie. This prediction can be helpful for the directors and the cast to make any updates to the movie based on the feedback from trailers and teasers. Ideally, we can infer that a movie is a success if a movie has more positive comments, high number of tweets and hashtags with its name even before the movie release. This means the success of the movie can be predicted based on how much reach and positivity it gained during its trailer or teaser release, and also based on the number of increasing tweets by the movie name. By this, we should understand that the pre-release buzz of the movie also plays an important role in predicting the success of the movie. The dataset we need for this movie success prediction can be collected from various sources where people write comments and reviews for high reach. We used Twitter to get necessary data for this project. Our project requires a huge dataset with all the keywords, tweets, hashtags, and reviews. We collected all this data from Twitter and stored them in CSV format. Here is the initial sample dataset for the Conjuring movie, directly extracted from Twitter comments and stored in the CSV. Here is the process flow of our project. I will go through this briefly and my friends can deep dive into individual topics when they continue. This project mainly involves four steps: data extraction, data cleaning, classification of data, and analysis of data. We made up a nice flowchart representation for our process. The first step is the data extraction. This step requires gathering all the necessary data that will be used for analysis and prediction. This is followed by data cleaning. As the data obtained from the tweets may contain unnecessary text, data cleaning is necessary to format the data into useful information which is readable by code for prediction. In the next step, data classification, we apply multiple NLP techniques to classify the data. Some of the classifiers which we used in this project are Naïve based classifier, SVM classifier, and keyword based classifier. The final step, visualization or analysis, is where the analysis and comparisons are made based on the classifier results using some data visualizations like pie and bar plots. Thank you.
Hi, my name is Rajshekhar Raghupathini, and I will be explaining you the steps of data extraction, data cleaning for attaining the perfect data set, and then one of the classifications that we have used, the keyword classification, which will be followed by an interesting visualization of pie charts for a couple of movies that we were able to gather the data sets for, uh, which will show us the results of how the keyword classification fared. We will start off with data extraction. It is a process of retrieving data out of data sources for further data processing. It's as simple as that. Here, for our project, we are extracting tweets from Twitter with the help of hashtags, for example, for teasers and trailers. And we are performing this with the help of Twitter Search API. And in the same way, YouTube comments of official trailers and teasers for the movies are extracted using the Google API Python client, and authentication is done with the help of Google Auth API. So the idea here is to take the help of the Twitter comments and the comments on the YouTube videos to attain a dataset which will give us the positive views and the negative views of the viewers, which will help us assess the result of the movie finally. The next step in the process is data cleaning. Quality of data is of utmost importance, and data cleaning is the process which would help in determining inaccurate, incomplete data to improve the quality. It is mostly done with the help of regular expressions, regex expressions. In this project, we have cleaned usernames, URLs, and encoded strings from the tweets, along with the emojis and white spaces. And we have also encoded the tweet and comments to UTF-8. The steps to perform data cleaning accurately are: monitor errors, standardize your processes, validate accuracy, scrub for duplicate data, analyze and communicate with the team. So for the process of data cleaning, we have considered raw data and passed this data to validate it and use split functions to clean it. We have also used this parsed data to find errors in it and have manually corrected it to improve the quality of data. The summarized data which we have obtained has been split into trained data, test data, and data profile. Training data is the actual data used to train the model. Test data contains the data which we can apply to the model. In this way, we have attained a perfect dataset, and now we can move on to the classification. Data classification is the process of analyzing structured or unstructured data and organizing it into categories based on the file type and contents. The first classification method we'll be using here is the keyword classification. Keyword classification is a name approach where you consider keywords from tweets to distinguish between each set. We have considered this to provide comparison and set benchmark against other results. This process involves calculating the occurrence of specific set of positive or negative keywords in a text. In our project, the categories into which the data will be classified are blockbuster, good, mediocre, and flop. The decisive factor for the classification here is the ratio of the positive to the negative keywords. If the ratio of positive to negative tweets is greater than 70%, the movie can be classified as a blockbuster, whereas if the percentage stands between 70 to 60, it can be classified as good, and 60 to 40 is classified as a mediocre movie, and any movie which gets a positive to negative tweets percent of less than 40% is considered a flop. We have two movies here, Robin Hood and Wonder Woman. Both the movies released around the same time in the year 2017. According to the box office results, Wonder Woman turned out to be a blockbuster, whereas Robin Hood is not a very great movie. It has a Rotten Tomato score of 15%, which indicates that it turned out to be a flop. Now, from the visualization pie charts we have, and using the keyword classification results that we have attained from our dataset that we used, that we have gathered from Twitter and the YouTube comment section, uh, we see that we have Robinhood has around 69.1% positive results, whereas Wonder Woman has around 69.4% positive results. Wonder Woman's results are perfect when it compared to the real world, but Robin Hood's results should have been somewhere around 40% or less, because it is a flop, and that's what our perfect classifier should be. ideally indicating us. So this shows us a need for a better classifier to attain better results. And now for that reason, let us now move on to classification using Navy base.
Hi, I'm Bhargav Rahul Survi. I'm going to talk about the next classifier that we have chosen to work with. That is the naive Bayes classifier. Naive Bayes classifier is a probabilistic classifier based on the Bayes probability theorem. It's one of the most popular text classification methods as it acts like a baseline for comparisons to other algorithms. It's very efficient for less volume of data, but it can also be scaled given the right parameters and pre-processing. The classifier considers each attribute to be an independent variable and does not form any relationships between them. Thus, it's a naive classifier. In our case, we use a multinomial naive classifier as we have multiple words with multiple occurrences of them. To help our classifier, we use a feature set consisting of positive words like amazing, super, etc. This feature set consists of more than 24,000 words. We then use these features to calculate the probability of a tweet being a positive tweet or a negative tweet. Here are the results of using the naive Bayes classifier. As we can see, this classifier is much more accurate than the keyword classifier as it uses a probabilistic based approach. We can see that it accurately predicts that the Robin Hood movie was a flop, as it has more than 63.6% of negative tweets. But it also fails to predict that the Wonder Woman movie was a huge success, as it found that only 50.8% tweets were positive. This shows us that there is a lot of room for improvement for this particular classifier. This brings us to our next classifier, SVM or support vector machine. This is a non-probabilistic supervised classifier. This classifier uses the training data to form support vector mapping that is used to classify the data. It is highly scalable and also works when there are dependencies between the data. An SVM model is a representation of examples as a points in space, mapped so that the examples of separate categories are divided by a clear gap that is as wide as possible. Then the new examples are mapped into the same space and predicted to belong to a category based on the side of the gap in which they fall, thus classifying the data into different mappings in the same sample space. To use this classifier, we have to train the model. For this, we use the same feature set as the naive Bayes classifier, which has about 24,000 positive words. Then we use around 21,000 classified example tweets to train our model. This model is then saved and used to classify our tweets. As we can see, this classifier provides us with the best result of all the three. It is expected as this classifier is trained and not naive, which is it can find dependencies between various features. This classifier predicts the flop of Robinhood by classifying around 67% of the tweets to be negative, and the success of Wonder Woman by classifying 72% of the tweets to be positive.
Hi, my name is Shrikar Reddy. As of now, my friends talked about the applications of this project in the perspective of public. But now I will talk about the applications of this project in the perspective of director and producers as well. Let's look into this graph. This blue is for SVM positivity and this red is for Bayes positivity, and these are the different movies. If we observe, for most of the movies, Bayes positivity is more. So we thought that we can use this kind of results for marketing. So producer will tell that we got good reviews for the trailers, and so that they can show these results, and then uh, public will be interested in these movies and they will attract more number of public, and as a result they will get more collections. Similarly, let's look into the negativity side. Same, this blue is for SVM negativity, this red is for naive-Bayes negativity. As we can see, naive-Bayes negativity is more compared to SVM negativity is more compared to naive-Bayes negativity. So director can have a look into these results and he can change the some clips of the movie to attract more public. So our project will also give reviews based on the language. Like we can select the language of the movie, English, Chinese, Telugu, something like that. And director can see which category of public has more positive results and more negative results. If English movie has more positive results, and on the other hand, like other language has less positive results, so he can change some parts of the movies clips so that to attract both kind of categories. So basically, these it will have more advantage if we run this application on the trailers because we can change some clips on the original movie. So this is how a director can change the movie and make it as a hit. I think the main difference between the results between SVM and Naïve is that because of the length of the comment length. Usually the length of the comments for the movie is like mostly 2 or 3 sentences at max. But we know that SVM performs good very well on the if the length is more and Naïve performs well on the shorter context. So that is why here Naïve is performing well because of the comments are of short length. Okay. Apart from that, the challenges what we have here is like what if a user is always biased to a hero or heroine like if he is a fan of particular cast he will be biased to that user and that will affect the review. And one more thing is popularity of a tweet will affect the mood of the followers. uh, Let me explain this more. Like if particular user is a popular like he has 10,000 followers or 1 lakh followers, if he tweets a tweet then his or her followers will also affect by that. Future work. um, I think this project has a lot of future scope which can give more number of benefits to both public and a producer as well. As we saw the two challenges in previous slide, the first challenge is what if a user is biased to particular user? How we are going to solve that challenge? The solution we came up for this is we can take the tweets of the particular user to the particular cache of previous movies. So, and then we can compare the his mood towards that movie and what is the overall review of that movie. The movie is flop and he is posting only positive reviews for all movies. Then it is like he's fan of that movie. Not that movie, sorry. He's a fan of that cast. So he's always posting positive reviews. So in those scenarios, we can reduce the weight of that review. And similarly, what if a user doesn't like particular cast? Then he is always going to post the negative reviews. And similarly, we can reduce the weightage for that reviews as well. So in that way, we can uh, totally balance the overall review of the movie. The second challenge we have is how the popular tweet can affect the mood of the followers. Let's say if a person has 1 lakh followers, then if he or her tweets a tweet like saying the movie is good, it is going to be one of the best movies, something like that, then all his followers will follow that. They will affect by that review and they will go to the theaters and producers can get more collections. So producers can approach such kind of persons and ask them to post some kind of popular tweets, positive tweets. Finally, we can train the user comments using convolutional neural networks to get better results, because even some tweets will have multi-level of sarcasms. So to overcome those kind of challenges, we can train our tweets in CNN. So this will go through multiple layers in a single tweet and eliminates most levels of sarcasm. Thank you.